It's Wednesday, the 10th of January. My name's Juan Brown. You're watching the Blanco Lirio channel. I've been digesting the final forensics report on events leading up to the disaster of the spillway at Oroville Dam last year, and now I'm ready to do a couple of videos now that we finally have the data, the hard data that we've so desperately been looking for this last year. And we'll do a couple of videos explaining exactly what happened at Oroville. I think this first video will do the sequence of events occurring right after the spillway failure. We've had a couple of good days of rain here in Northern California, overfilling the rain gauge. Overall this year, 2017-2018 rain season has been very dry. The last couple of days of rain have just barely brought us close to average rainfall this year. The flooding you're hearing about in Southern California has nothing to do with the situation at Oroville. Currently, the Oroville Reservoir is still at 700 feet, nearly 130 feet below the spillway gates, and still 100 feet below the new recommended flood protection level of 800 feet, and 150 feet below the normal flood protection level of 850 feet. With the information from the forensics team report, this graph, this data now tells a very dramatic story of events that happened when the Oroville spillway failed.
Norm, we didn't see more. Oh, there goes more cement. More chunk cement just came up.
First, let's start with an overview of the Oroville Dam and associated facilities. This is a view of Oroville Dam before the February 2017 incident, showing about a nominal lake level of 850 feet. Here's the main dam, the earth-filled main dam, the tallest dam in the United States. It's 722 feet tall from top to bottom, but the elevation at the top of the dam is about 922 feet above sea level. We're going to rattle off a bunch of different elevations of these components because it's critical to the understanding of events. To the left of the main dam is the service spillway, the main spillway chute, bottom elevation 813 feet. The spillway itself is about 180 feet wide by 3,000 feet long, dropping nearly 500 feet in elevation. To the left of the spillway is the emergency spillway. Top of the emergency spillway, 901 feet. That emergency spillway continues out this direction over the old boat ramp at the same elevation, 901 feet. Below the dam is the Hyatt power plant, and below the Hyatt power plant is the Thermalito afterbay, often referred to as the tail race in the forensics report. The elevation of the Thermalito diversion pool, or tail race, is controlled by a diversion dam well downstream, and that elevation is controlled or preferred to be kept around 200 to 225 feet above sea level. If this water level rises above 250 feet above sea level, the Hyatt power plant will begin to flood. This entire project was completed in the year 1968. Here's another view of the Oroville Dam and structures looking from north to south, and now you get a better idea of the massiveness of the main dam separated by this high terrain from the spillway and emergency spillway. Remember, this is an earth dam, and under no circumstances can water ever be allowed to top an earth-filled dam or it will fail. Here on the main spillway you can see the unarmored entry into the spillway, and then the OG Weir emergency spillway, which spills onto just raw dirt below. This emergency spillway had never been used before February of 2017. Here's a view of the cracks and joints in the spillway that eventually led to its failure. And that gives you an idea of the size of these cracks. That's also spalling indicated right in here, not cavitation. Here's another view of the cracks, and this is rebar exposed by spalling and breaks in the rebar. We'll get into, in a separate video, the actual physics of the failure of the spillway itself. Here's a view of the spillway in operation on February 3rd, 2006. Note the drains, the water coming out of the drains along the spillway. Again, we'll talk more about that in a separate video. Here's a view of the initial damage to the spillway when they first shut off the gates after discovering the problem. And here's a view of the ultimate damage after the incident. Now here's a good picture showing just about where they believe the incident occurred. Started right about station 3300. You can see the water being disturbed by one of the old patches. This was the beginning of the end of the Oroville spillway. Just want to show one video of original construction. There's the original rebar that went into the spillway for all those that are claiming that there was no rebar in this spillway. There certainly was. Here's an overview during the incident. The failed part of the main spillway right here. Debris flowing into the Thermalito diversion pool, backing up, threatening to flood the Hyatt power plant. And erosion on the emergency spillway, erosion so severe that caused the evacuation of 180,000 people. So now let's look at the timeline and the drama behind that timeline. I also want to point out this one transmission tower. This one particular transmission tower played a much larger role into the decision making than I had originally known about during the event. There's several other transmission lines in the area here that are also threatened to get wiped out by erosion. This one threatened to get wiped out by erosion from head cutting of the main service spillway, and the other towers threatened to get wiped out by erosion from the emergency spillway. Remember too about the Hyatt power plant. Electricity is required, the Hyatt power plant is required to be connected to the grid in order to operate. You cannot drain water out of the Hyatt power plant unless it is connected to the grid. So that being said, let's review. There are 4 ways to get water out of Lake Oroville. Number 1, the RVOS, the river valve outlet system located deep down in the original diversion tunnels of the Oroville Dam, capable of maybe about only 4,000 CFS. Method number 2, releases from the Hyatt power plant capable of about 17,000 CFS if all 6 turbines are running. At the time of the incident, the river valve outlet system was already out of service due to prior issues, and the Hyatt power plant has had 5 out of 6 turbines operational. 1 turbine was previously out to be rebuilt before the incident. The next way to get water out of Oroville Reservoir is through the main gated spillway, which can control water levels between 813 feet, the bottom of the gated spillway, and up to 900 feet, the maximum capacity. And the emergency spillway is just that, only to be used in the event of an emergency. At an elevation of 900 feet, the water will just simply pour over the top of the emergency spillway, down through the dirt embankment, and into the Thermalito diversion pool. At the time of the incident, with the river valve outlet system being in op, the Hyatt power plant under the threat of being flooded, the main gated spillway being busted and being basically stuck at a flow of 50,000 CFS, and the emergency spillway unsuitable for use, they were down to less than 1/2 of one option to get water out of Lake Oroville. So why did erosion at the emergency spillway cause an evacuation of 180,000 people? The erosion was excessive enough that engineers on the scene were concerned that this erosion would eat back into the emergency spillway and possibly topple a portion of the emergency spillway, causing a flood of water from the emergency spillway into the Feather River. Here's a view of sandbagging operations at the Hyatt power plant in an effort to prevent flooding. And here's the numbers timeline that tell the drama. Down here is lake elevation. The lake was at the correct 850-foot elevation, the flood control level before the incident occurred. And the lake level rose up to 900 feet. There's where it begins to spill over the emergency spillway, and then was brought back down to 850 feet and is now today down to 700 feet. Here are the inflows, shown in blue, spiking up to over almost 200,000 CFS on 9 February from the extreme heavy rainfall events that were occurring at the time. And here's the outflows, and this shows the decision-making process of this incident. And right here was where the mandatory evacuation order was given. As an airline pilot, the preponderance of our training is spent in learning to deal with emergencies and working together as a crew. Folks that own large, complicated projects like the Oroville Dam are required to do potential failure mode analysis. In both cases, these typically deal with individual emergencies. The situation at Oroville was a compound emergency. The situation at Oroville, according to the report, was just as I suspected, a sequence of events that was never really considered in their potential failure mode analysis. Why? Though some of these potential failures were considered, like failure of the spillway or failure of the emergency spillway, they were generally considered too unlikely to spend a lot of time studying. Instead, folks at Oroville spent the most of their time studying potential failures of the dam itself. After 5 years of drought, the 2016-2017 rain season in Northern California started off with a bang after a series of atmospheric rivers, better known or formerly known as Pineapple Expresses, slammed into Northern California. Yours truly was out reporting on local flooding here in the Nevada County area for our local paper, the Union newspaper, when on February 7th, about 10 a.m. in the morning, this happened at Oroville. While the spillway had been used intermittently over the last couple of years, this was the first time the spillway had been cranked up above 10,000 CFS flow since 2011. When the spillway failed, the flow was just being increased from 42,500 CFS to 52,500 CFS as the lake rose fairly quickly from 850 feet to 855 feet. Due to the high inflows of water from the big storms. Ironically, 2 DWR employees were down next to the spillway repairing the emergency evacuation siren when they heard the explosion and the beginning of the end of the Oroville spillway. At the same time, the hikers were on the other side of the spillway recording this video. So here we are at this point on the graph, February 7th by 12:30 in the afternoon. The gates are shut down and the flow reduced to zero. And operators begin to inspect the damage and come up with a plan. While folks are peering down the giant hole left in the spillway, contractors are called up and brought onto the scene and asked, "How quick can you guys fill that hole?" Contractors tell DWR, this is a matter of weeks. DWR says, "We only have a matter of days." DWR immediately realizes the longer they wait here, the more water they're going to have to release over the emergency spillway later on as inflows raise the lake rapidly. On the 8th of February, operators try a couple of tests on the broken spillway and crank it up to about 35,000 CFS. Briefly, drop it back down, check for damage. Ramp it back up, drop it back down, check again for damage. It becomes abundantly clear that these low flows cause more head-cutting damage and that the possible sweet spot is going to be to ramp it up to nearly 50,000 CFS and plunge that water over the edge and down into what is now beginning to form the plunge pool. Meanwhile, lake levels continue to rise and a new storm is brewing and about to hit at the worst possible time. At this point, operators are abundantly aware of several different features. One is head-cutting erosion of the emergency spillway cutting back and getting into the gate structure would be disastrous. Also, head cutting erosion, cutting back just a bit and taking out this transmission tower, is going to pull down all the lines and remove the Hyatt power plant from the grid, preventing operation of the Hyatt power plant. If they flow too much water out of the main spillway, too much debris is going to fall into the tail race or thermal-ledo diversion pool and cause backing up of water and potential flooding and loss of the Hyatt power plant. Also of concern is, based on the amount of erosion they've seen under the main spillway, what does the geology look like now under the emergency spillway? Was the emergency spillway built on the same crummy, weathered rock that the main spillway was? If so, if we top the emergency spillway, what are the chances of that structure surviving? Meanwhile, operators order grubbing and cleaning of this slope in preparation for a spill by the emergency spillway. Abundantly clear to everybody is the longer they wait, the more likely this emergency spillway will be used. At this point, a big debate erupts between what the report calls geology versus executive regarding the importance of saving the Hyatt power plant versus the danger of spilling over the emergency spillway. Geology is concerned that a spill over the emergency spillway may be more dangerous than the threat of flooding the Hyatt power plant. Executive is more concerned about not losing the Hyatt power plant. Why? Because they understand that that's the main way to control the Oroville lake level throughout this emergency, after this emergency, during this repair of the spillway, and long term in the long run. The executive side of DWR wins the debate to save the Hyatt power plant, and on 10 February makes the fateful decision to cut back outflows from 65,000 CFS down to 55,000 CFS in an effort to minimize the amount of debris going into the thermal-ledo diversion pool and reduce the threat of flooding the Hyatt power plant. Hydrologic models are tweaked such that the lake will just peak out a little bit above 900 feet, and the emergency spillway will be used for a short period of time. On February 11th, 2017, the emergency spillway begins to flow for the first time since it was built in 1968. Less than a day later, major head-cutting erosion on the emergency spillway is noted. Geology argues with executive that again we need to increase flows in the main spillway here on February 12th and relieve the pressure on the emergency spillway. Management wants to keep, or executive wants to keep the flows at 55,000 CFS as the tail race is within 6 inches of flooding the Hyatt power plant. At 3:44 p.m. on the 12th of February, the mandatory evacuation order is issued. It's not clear in the report who made that decision, but it is made, and simultaneously outflows are cranked up to 100,000 CFS to relieve pressure on the emergency spillway. Water levels continue to rise in the thermal-ledo diversion pool, 2 feet above the flood elevation of the Hyatt power plant, but due to the heroic efforts of the crew using jury-rigged seal covers designed by the O&M staff, the Hyatt power plant is saved. With outflows of the main service spillway at 100,000 CFS, the lake level quickly drops below the level of the emergency spillway, and soon the mandatory evacuation is turned to a evacuation advisory, leading to massive confusion to all of the folks downstream of this incident. Eventually, on the 16th of February, flows are ramped down to 80,000 and eventually ratcheted back down to between 60 and 50,000 CFS for the rest of the season, maintaining control of the Oroville Reservoir over the busted main spillway. The report emphasizes two major decision points that sealed the fate for this emergency evacuation. One is this point right here on 9 February, where they slowly ramped up the outflows of the main service spillway to 65,000 CFS instead of rapidly raising it. And again, the decision on 10 February to reduce outflows from 65,000 CFS to a steady 55,000 CFS. Again, these were decisions made by executive in an effort to save the Hyatt power plant from flooding due to excessive debris in the Thermalito diversion pool. So as you can see, this is an incredibly stressful emergency situation by all those involved. And the idea here is not to do any Monday morning quarterbacking and second guess any of these decisions. The idea is to look at the decisions that were made and learn from all of this. This is going to be a textbook study case for everybody involved in this industry. If you found this information useful and helpful in understanding of events at Oroville, please hit like and subscribe, and thank you for your continued support of this station. I hope to get in the air and get a look over Oroville as soon as the weather clears, hopefully as soon as tomorrow, and we'll continue our updates on the rebuilding of the Oroville Spillway. More work is going to be done this year, 2018, than was already accomplished in 2017, so lots to report on. Stay tuned.